So just a little bit about touching base about the basics of central tendency, how like we can represent a group data using the central tendency measures. So a central tendency measure is a single index that can be used to represent an entire set of measures of a group. So we collect data from people. How can you represent or how can you interpret and summarize the group statistics? So this is a convenient way to summarize data, and the three commonly used indices for most of the extension reporting and also for social science journals are mean, median, and mode. We'll see what these three mean. For some of us that may be not very familiar with social science statistic kind of a thing or quantitative data analysis. So mean or an arithmetic average is the most widely used measure to depict like a group. So this is a sum of all the scores that you'll collect from your surveys in a distribution by number of the cases. So these observations can be age, farming experience, or any other experience. Like there are 5 observations here, 14, 15, 16, 17, 18. So we'll add all of them up and divide by the number of observations. That will be 80 by 5, which will be the average score, the mean for this distribution. The next measure is a median, which is kind of the central point in a distribution below which 50% of the cases would lie. So again, like if you take an example of 14, 15, 16, 17, and 18, so these can be the data that you get from your surveys. Again, anything like an experience, how many years you are working in ANR, if you want to represent that for the group. And this is one of the measures that you can use. So this median is useful when there is a scatter, like when there's more scattering in the distribution, like Roshan will talk a little bit more about it. And so the other example is the median, the middle point when there are even number of cases is taking the average of the middle two numbers. Then the last commonly used one is mode. This is the value that occurs most frequently or commonly in a set of scores. So in the first example, we can see that 19 is the mode, that is the frequently occurring number. And in the second distribution, there are 2 numbers that are frequently occurring. So that is a bimodal distribution, and we can have like a trimodal or a multimodal distributions also. In addition to reporting an average, the measures of variability, to give like a full picture of a distribution of the people that you are trying to represent, the variability is also very important to report. Like my experience has been that we see a lot of reports where they don't report variability, which is not a recommended practice. Because the mean values or any average, like any central tendency measure you may choose, may be identical, but the type of variability or the scattering within that set of observations may be different, right? For example, if you see the 2 examples A and B, the mean score, the average is still the same, but we can see that it starts at 10 and there is a 35. So there is more scattering. So it is really important whenever you are reporting descriptive data, you have to report both mean, median, or like a measure of variability. So the commonly used indices for variability is standard deviation, and you can also use range. Range is the difference between the highest score and the lowest score in the data that you collect. So in this example, the range will be the highest is 16 and the lowest is 2. So the range will be 14. And then the deviation scores, the standard deviation is the difference between like an individual observation, like individual answer that you'll get from your survey with the mean of the distribution. So we'll be able to see how much an individual observation differs from the group mean score if you use this measures of variability. And as I said, the commonly used index is standard deviation. And now today, one of the methods that we are going to focus on is how to use frequency distributions to understand the pre and post test data and how to interpret and report the analysis. So frequency distribution is a systematic arrangement of individual measures from the highest score to lowest score. So you can arrange it in a descending order. And it is basically counting how many times each category is selected in a question. Like if you have a scale, like strongly disagree to agree or whatever lowest to highest. And it is basically counting how many people have responded in each category. And these can be graphically presented using different visuals like histograms, frequency, polygons, error bar, and box plot. And Roshan will talk a little bit about the outlier detection. Again, the scattering that we were talking, why it is important to focus on the outliers is something that Roshan will talk now. Roshan, please.
Bikram covered about the frequency distribution to see the distribution of the data. So it is possible that in the frequency distribution, we may find one or two data points or many data points that is considered to be not normal. That means it's far away from the scope of the normal observations for that variable. And that's what is an outlier. For example, in this graph, you can see so the data was collected, like how many hours per week a student watches TV. So you can see its distribution is from 0 hours to 72, but there is a data point which is beyond 72 hours. So you can tell that maybe this data point looks outlier, or the last 3 data point is outlier. So it is important to detect those outliers, because that will have effect on your variable estimations. So the best way to detect these outliers are to draw histograms or scatter plots, and one of the best method is to make box plots. Box plots would be very helpful to detect those outliers. So the presence of these outliers in your sample could be because of their true presence in the sample, or could be by manual error. For example, when you try to enter the data, maybe you did some mistakes while entering the data. So in that aspect, it's important to know whether that is a human error or this is the true presence of the data in your sample. So next slide, please. So in the next slide, you can see this is an example of a box plot, and the box plot is what it creates is it divides the observations in 4 equal groups. Then you have a minimum, you have a maximum, then the first quartile, and the median, third quartile, and the maximum value. And the difference between the first quartile and the third quartile, we call it interquartile range. And this interquartile range usually helps us to determine whether the outlier is a potential outlier, or is something problematic. So to know whether it's a problematic outlier or a potential outlier, there is a calculation. What we do is we first calculate the interquartile range, which is the difference between the third quartile and the first quartile, and then we multiply it with 1.5. So any values which is beyond the 1.5 times the interquartile range beyond the third quartile could be a potential outlier. Or if it's 3 times larger than the third quartile or below the first quartile, then it could be a problematic outlier. So, but it all depends on your context of your study. So if you don't have any reasons or any explanations to define whether the presence of the outliers in your data, so it should be advised to include both the analysis, including the outlier and excluding the outlier in your reporting.
Okay, thank you, Roshan.
Thanks.
Yeah, so as Roshan just said, both positively skewed data and negatively skewed data has to be kind of taken care for the outliers. So now I will get to the methods that we can use to report, to analyze and report the pre and post test data. So within frequency distributions, this is one of the methods. We are not going to focus on this one today. This is something that we have been asked to do more these days, and it is Roshan's experience that submitting this kind of an analysis is being accepted by agencies like NIH also. So basically, in this method, what you can do is, so there are these, for example, 2 questions from a 4H evaluation that I conducted. So one of the questions is understanding of the students about knowing how sunlight can affect plants. So there is this 5-point scale, 4 and 5 are high understanding. So you just add up the top 2 scale 2 points, high and very high, and then report the percentage point change. So that is one of the methods. But if you choose to adopt this method, which I've been asked to do for one of my recent journal publications, it's very important to not miss the point that this is not percentage change. We are talking about percentage point change. So that's really important to indicate that like the difference between 52%, 93% and 52% is 41 points, not 41, like it's not 40% or 41%. So the second method that we are going to focus on today and also do the activity is to see how many points your training participants have moved before to after attending your educational program. So we can use, like, if it is a 5-point scale, the maximum change possible in either direction is 4 points, right? So we'll calculate the frequency distribution for the change score for each of the points and then depict that as the frequency distribution. So in this example, we can see that this was from a soil health online course that was offered to NRCS, the Natural Resource Conservation Service professionals. And one of the questions was, what is your level of understanding of how the physical characteristics of soil contribute to soil health? And the scale was no understanding, slight understanding, moderate understanding, good understanding, and excellent understanding. So what we have done, the way that we reported was to report the frequency distribution for the point change. You can see like four people out of 30, like 30%, around 30%, did not show any change from pre to post, whereas there were like 6 people who had a 1-point change. Again, in this method, we can only know if they moved by 1 point, but we really don't know like if they moved from slight to moderate or good to excellent. So if you want to do that, then there is a deeper level that we have to go. But for this activity today, we'll focus on how to calculate the point change and report it. So this kind of an analysis compared to comparing mean scores that Roshan will talk about later in a t-test gives us a different kind of understanding, right? This can be used more for program improvement, for example. Because in t-test, all you know is whether or not the groups, like if there was a significant betterment or change in understanding or the mean scores from pre to post. But we really don't know how many people changed by how much. And also we'll see in this example that you're going to work on today, that the same data set shows us 2 different types of findings for the same data set using this method and then the t-test. So now we'll move into the activity. Cindy has a question. Is there an option in UCANR survey tool to ask them before? So Cindy, by survey tool, you mean Qualtrics kit?
I think she means the ANR portal survey. I don't think there is a really easy way to do in the ANR survey tool. I would ask them as 2 separate questions. But in Qualtrics, there is the matrix question type where you can do 2 different columns, a set for before the training and a set for after the training. Okay.
Okay, so these are like you would have received 2 Excel files from Clean yesterday. If you can pull out the FD, the frequency distribution example, that's what we'll be using. So these are the steps. I'll demonstrate now how to run this in Excel. And after that, we'll break into rooms. And then you can run this in the data set that you got yesterday. And then what we want to do is, like, after you run it, please come up with 2 or 3 sentences of how you can report that, like, or how you can use that to inform your programming. And that is what we'll share back when we meet as a group. So Kit, now I'll stop sharing this and share the Excel to demonstrate this. Can you please read through the steps so that I can just follow that?
Sure.
Okay.
Do you want me to read the instructions to you now?
Yeah, so I'll follow step by step, yeah.
Calculate question 1 change in sheet 1, B minus A.
1 minute. So here you hit enter and then you subtract the after score from the before score, hit enter, and then that will give you the change score, and do that for all the observation, all the responses. Then
Second
hit.
is calculate frequencies in column I using count if.
Okay, so this is column I.
I think there was a mistake made in that calculation. Q1 after minus Q1 before doesn't equal 3. Can you look at?
Yeah, the formula wasn't there. You have to do B minus A, B4 minus A.
Oh, okay, sorry, I forgot.
Good catch.
No.
Okay.
B4 minus A4.
Okay, sorry for that. I forgot.
And there's
Okay,
there's a trick where you can double click the bottom right of a column and it'll, or of a cell, and it'll auto populate, but next time.
okay. So next is like this, you will see the frequency, right? That's what we want. So click on column I here and hit this function f of x. It will show this count if. Double click on that. And then the range is all these scores that, for which we want to calculate the frequency distribution, the change scores. And the criteria are all our point changes that are possible. So here it is -4 for the first cell, and then hit done. So you'll see that there is no observation that has like changed by -4 points. So you repeat the same thing for all the other criteria. For example, let's see, because there may be some scores with 0, right? So f of x, count if, and the criteria we want is no change, 0. So this. Range is all this. And we want the criteria is no change from pre to post, that is 0. And you hit done, there are 9 scores, 9 people who have not changed. So this is what we want you to focus on today, because there are quite a number of people that haven't changed as a result of the training, their understanding about the use of program logic model that is not possible to detect in a t-test. So you do the same thing for all of the other criteria, the changes possible, and then you will populate this.
Vikram, you have to do the percentage too, column J.
Yeah, so percentage is basically your observation frequency by the total number of the sample size, which is 30 in this case. 30 people responded to the survey, and click enter and it gives a percentage. If it doesn't give a percentage, then click on this cell and then hit percentage here. So we'll populate all this and then fill out this table, and the groups will come up with 2 or 3 sentences of how they can report this. So now we'll break into briefly talk about a little bit about inferential statistics and the test that we'll be doing now. And after that, we'll break into groups for the activity. Roshan, please.
Yeah, thanks, Vikram. So far, we covered the distribution, the frequency distribution and outlier outlier detection and the point change. So most of us, we know about, we have descriptive statistics, descriptive analysis, and inferential statistics. So inferential statistics is something that we use when we try to make some inferences from the data that is available from the sample. And the data, the samples from is used to make inferences or to generalize to the population, those estimates. So there are like two main reasons for using the inferential statistics. One is to for estimation purpose, and the other one is to test the hypothesis. Estimation purpose is when we have the sample data and we will try to estimate the population parameters. And then the other area where we use inferential statistics is to test the hypothesis. The hypothesis, which are based on our underlying theories that you use for our programs, or we make some predictable the claims that, and those claims can be either can be accepted or rejected based on the hypothesis testing. And also the test of significance is the types of statistics that we use to test the significance level, whether this is in real the change, or is it something like by chance those changes has been happening. Also, so all this inferential statistics will start with a null hypothesis. The null hypothesis is something like what the example is here is there is no statistical difference observed in the relationship between the two variables, or in the association, or the differences between two groups, or the effect is not significant, or whatever the observed data says is just a function of chance. And some of the assumptions that needs to be considered while using the inferential statistics, the priority should be given to the normality assumption and the assumption of homogeneity of variance. The normality could be different in a different context. For example, the kind of analysis you are doing. For example, if you are doing a regression analysis, we assume that the normality in the errors. But in our today's webinar, we are focusing on the t-test. So for the t-test, we assume that the sample distribution is normally distributed. So the question would be arise like, what is the minimum number of individuals or participants we need to make this assumption? So based on the central limit theorem, if we have 30 or more, so and that this distribution could be a normally distributed, because, and then when the sample size increases, it tends to be normally distributed. Then the homogeneity of variance. So the assumption is that the variance should be same throughout the data. So for example, if you are taking samples from one population, and we assume that the variance remains same in all the samples. And again, we talked a bit about the interval data, and we'll be talking more about the interval data in the coming slides. So data should be measured at least the interval level or the ratio scale. And then the last assumption is the assumption of independence. So when we are collecting data using our surveys from individuals, we assume that the one's way of responding to a survey or responding to the attitude questions or behavior question is not dependent on other surveys data. So this is that means individual participants, the way they are responding to the survey is independent of the other response. And then, so again, the independence depends on the types of tests that we are doing. So for example, the t-test, we assume that the sample, the pre and post sample, or maybe the two groups are independent with each other, independent of each other. So one of the most widely used tests to determine whether the difference between the variables or two samples, whether it's significant or not, is the t-test. And the t-test T-test could be a one sample T-test or independent sample for independent sample T-test or dependent or paired samples. So one sample T-test usually that we are not covering in this in our webinar is when we try to compare the sample mean to estimate the populace to estimate the population mean, or whether to see whether the population mean is different from the sample mean. That's a one sample T-test. Then the independent sample T-test could be when we have like two samples and we try to compare the means of two samples. And the paired samples is when we have two. The easiest example would be a pre and post test where the individuals take the pre-test and we collect the data from there, the same sample again at the post-test. That's a paired sample where the number of individuals responding to the pre and post remain same in the analysis. But in the independent sample, it could be possible that the two samples could be varied based on their sample size and also the variance. Next slide. Independent sample t-test, as I mentioned, this is a two samples, a two group, and where we compare, we usually compare the variables after the treatment has occurred to see whether the two groups are different based on the statistics. So there is an example is comparing mean of test score on two sample groups. And one group is taught traditionally and one group is through the online distance education. So again, going back to the ways that the independent sample t-test can be done is you have to look for whether the sample have equal sizes or they are different, and what kind of assumption you are considering, whether you are considering equal variance or you're not considering equal variance. Based on that, the statistics will change. The another one is the commonly used for to see the difference, to test the significance of the difference between the pre and post is the paired sample t-test, which is for example, the one we did it in our the point score change exercise was a pre-post test score, the mean comparison. So in this the t-test we in the social sciences, we consider the 90% level of significance for our test statistics. So we'll be covering that. So one of the things, this is just for the publication purpose. We are not going to go into detail on the type 1 and type 2 error. Mainly, if you see in the journal articles, they usually mention the type 1 error. Type 1 error is basically when you reject a null hypothesis. When the null hypothesis is true, that means for example, at a 95% of confidence into 95% level of significance, statistical level of significance, you are rejecting a null hypothesis. That means there is still a 5% chances that the null hypothesis is correct. And that there's an example. This could be a false alarm that you will think there is something is happening, but in reality there's nothing happening. It still remains the same. And the type 2 error is the quite opposite way, when you accept the null hypothesis but when the null is true. In this case, that means the programs or maybe the situation needs an interventions, but you miss to report or to document that the need. And this is and that would be a result of type 2 error. So if in the journal articles or publications, you'll most probably see the type 1 error that are widely reported. And the level of significance, again, is in social sciences, we usually use 95%. And the more you go close to towards 99% is that it has more power, the statistical power. And the p-value generally reported for 95% of level of significance is 0.05. 0.05 is like you are 95% confidence that you will capture the true population mean or population estimate. And there is still the type 1 error here is the 5. That means there is a 5. The error could be I think I can read it correct. Yeah. So the relationship being caused by, or the error or chance of mere luck is just 5%. This is like the 5 out of 100 times there could be an error that you are rejecting the null, but the null is true. That is again the type 1 error. For p level of 0.01, again it's a 99% of level of significance here. That means 1 out of 100 is by chance or by luck. So I would like to see if you have any questions regarding the level of significance or inferential statistics or t-test or anything before we go to the paired sample t-test in the Excel sheet.
I have a question about the level of significance.
Sure, Carrie.
Relationship to the sample size.
Mm-hmm.
So if we're talking about trying to find significance in a pre-post test, for instance, but we've got a pretty small sample size, the class is fairly small, or the people who were taking the training or whatever was fairly small. How large does that sample size need to be before we can really state any significance?
So one of the, as I mentioned before, the theory of central limit, the central limit theory says that when we have at least like a 30 or more, the sampling distribution will tends to be a normally distributed one. So if we have 30 sample size, that we are in a good position to make those inferences using the correlation statistics or t-test statistics. 30 is the number that usually reported in the social sciences.
Okay, so if there are any other questions, we can follow up later. In the interest of time, we'll move on to the activity. I just want to add something to what Roshan said. If the sample size is less than 30, we can opt for non-parametric tests like Mann-Whitney, where we, instead of comparing the mean scores, we can compare the median scores, because we are not assuming, like we are not sure about the normality. So if we have any such situations, again, we can do that one-on-one. As I said, in the interest of time, we will move to the activity. Kit, can you please do the same thing? I'll share the Excel and run through the steps, and if you could please read it.
So the first step is under the data menu, select data analysis. So we had sent over some instructions prior to this workshop that you have to install the data pack in order to see this data analysis icon.
Okay, so this one, the far extreme side is the data analysis tab. I'm clicking on that. Next step, please, Kit.
Choose t-test paired to sample for means.
So this dialog box will pop up, and then you use the t-test paired to sample for means, pre and post, right? So it's paired dependent samples. So I selected that, and I'll click OK. And the first variable, yeah, please Kit, read out. Can you please read out?
Specify the range of cells containing the data for variable 1.
So I already selected this is the specified range of cells for variable 1. And be sure to select the header also, so that it will get into the output.
Mm-hmm.
So we do the same thing for the variable 2 here, the after training data. And then for the purpose of today, yeah, please. Yeah.
The labels box should be checked, which you have on the screen there.
Yeah. Then as, yeah. What's the next step, Kit?
That's it.
Okay, so I'll just mention a couple of things. As Roshan was just mentioning, in social science research, we are okay with a level of 0.05. That is, we are willing to take a 5% risk of our results being as a result of chance factor. So 95% of time being right is acceptable for us. But if you want more statistical power, you can go to 0.01, just changing this to 0.01. But that is, as I said, like in clinical trials where you have more control over the variables, other variables, you can go for 0.01. But for our purpose, 0.05 is good. And the hypothesized mean difference, you can leave it blank for the purpose of today. But if you have a logic or a theory stating that you want to test for a certain range of difference, you can input that number there and then hit OK, right, Kit?
Yeah.
And that will take you automatically to a new worksheet. So just click on those columns. And what is the next step, Kit? That's it.
Excel whips out an output table. There's lots of info. What you're after is the p-values. Calculate the standard deviation for both variables.
Okay,
So,
yeah, okay. So briefly about the table, all we are interested in is this p-value. And as you can see, this is less than 0.00001, so it is statistically significant. So the mean difference, it was 3 on a scale of 5 before the training. Understanding of the program logic model, we are using the same data set here. The main purpose of using the same data set was to see what kind of results you can get from the same type of data and what kind of understanding you'll have. So there is almost near to 4 after the training. So this Excel output, it gives like a variance for t-test, but usually the reported one is standard deviation. Unfortunately, as far as I know, it doesn't calculate standard deviation. So we'll do it manually. The formula, Kit, can you tell, please?
equal sign SQRT and then B5.
SQRT and then select our mean score. Sorry, the variance.
Variance B5, yeah.
Yeah, and then it gives the standard deviation 0.93 for before and 0.74 for after. So smaller the standard deviation, the scatter, more the individual scores are closer to the mean. So we want ideally like a lesser standard deviation. And after that, there is this tab that has an example, like an example format of how to report the t-scores, t-test. So this is an example. And what is the last step, Kit? We want them to fill this out, right?
Just fill it in, yep.
Yeah. So we'll do the same thing again. Again, as I said, we are worried, like all we are looking for is this p-score. And the sample size is 30. So we'll again break it to similar.
So scales of measurement. You can see my screen, right?
Yeah.
So this is the process through which observations are translated into numbers. It's all about assigning numbers to objects or events according to some rules. We'll talk about 4 of these different scales: nominal, ordinal, interval, and ratio. So nominal are the ones, like I like to think of these as names, things that you kind of assign names, numbers to names, which means there's really no quantitative difference between these things. They're just qualitatively different. They're 2 or more, they're mutually exclusive categories. The relationship between them is that they're different from each other. They don't represent more or less of anything. So examples are gender, religious preference, party affiliation, marital status. And then changing the assigned numbers of the codes doesn't make any difference. Ordinal is ranking with respect to how much or little or how much they attribute, how much of an attribute they possess. They can be ranked, but without indication of the degree of the difference between them. So one of the surveys questions that I always like to use is satisfaction. So very satisfied, somewhat satisfied, not satisfied, etc. Those are examples of ordinal scales. Other examples are football rankings, guilty, not guilty, other opinion scales. And then intervals, they order objects or events, but they have equal intervals between the units. The equal differences in the numbers represent equal differences. So examples are Celsius temperature, IQ tests, educational tests. In this case, there's no absolute 0. 0 doesn't mean the absence of something. So when it's 0 degrees outside, it doesn't mean there's no temperature. It means it's very cold. It's 0 degrees, right? So it can't say that a student receiving a 0 on a statistics test has 0 knowledge of statistics. And then the last one is, I always think of the ruler, has equal ratio, has equal intervals as well as the true 0 point. A yardstick can be used to measure the length of units in inches or feet, an absolute 0 corresponding to no length at all. Examples are work experience, farm income, milk production, test weight. So now we have a poll for you. If you could run the poll, Clint, there are 4 questions in the poll. So on the slide here are 4 questions. And for each of the questions, you're going to tell us, is it nominal, ordinal, ratio, or interval? And so the first one is, what was your annual farm income in dollars last year? The second one is, what was your annual farm income in dollars last year with a scale that people can respond to, or kind of closed-ended responses that they can respond to. The third one is, do you have any non-farm income sources? Yes, no, or prefer not to say. And the fourth is, what is your overall grade point average in your undergraduate program? So go ahead and answer the poll. I'll close the poll as soon as we have mass responses.
And also, Kit, why? Just wanted to add, why